Welcome to another tutorial of Proflan YouTube channel. In this video, we're going to have a discussion of the topic inequalities for pure 1 Edexcel math. So we're going to have a detailed discussions and get to see what are the questions that have been tested in various questions in various exams and previous years, so that once you are able to go through those questions, you'll be in a position of attempting and doing other questions in your coming exams. If you are new to Proflan YouTube channel, consider subscribing and also leave a comment down below if this video was helpful to you. So we need to move to the first question, and in question 1 here we are told that the figure shows part of curve C whose equation is y equals to f of x, and f of x is 2x squared minus 12x plus 4, and then we're supposed to write 2x squared minus 12x plus 14 in the form a into x plus b squared. So we are going to use completing square so that we can be able to rearrange this equation. We make it in the form that is expected there. So the first thing that we're going to do, we're going to pick the equation that was given, the equation that we were given there, and then I'm going to group the first two terms with x. We can introduce bracket and then factor out the factor out 2, because it can be able to divide the two terms. So we are going to reduce into this, and now you see, if we are going to complete the square, x squared minus 6x, we are going to say x minus a half of 6 is negative 3, and then squared, then we subtract the square of 3. Now, if we open the bracket, we shall have 2 multiplied into all the terms that are in the bracket, and eventually this is what we are going to have, which is the expected form that we are supposed to leave in this particular question. Now, when you complete a square like this, you may use this information in order to state the maximum or minimum point of the curve. So in order to get the coordinates of the turning point or maximum point, minimum point, you look at what's inside the bracket. Like for instance, here we are having negative 3. So when you are going to pick the x coordinate, you are going to take the opposite sign of 3, and that becomes now positive. Yeah, we shall have this turning point that would be now positive 3 comma 4, the way it is, and that becomes our answer in that case. Moving to the next part, in the second section, that is third section, that is part C. Here we are told that the line L intersects C at negative 128 and at P as shown in the figure 5. We are supposed to find the equation of L, giving you an answer in the form y equals to mx plus c. So something that we need to remember is that whenever we are trying to find the equation of a straight line, the first thing that we ought to have is the gradient of that straight line. And remember, for you to find the gradient of a line is change in y over change in x. So I'll expect you to go and identify this coordinate because you have obtained it, and we also have the other coordinate as negative 128. So which will mean that we can now come down here and write the coordinates and then use these coordinates in order to work out the gradient of this line L. So to get the gradient, this is the formula we're going to use, and we can now identify this as our x2, y2, and this to be x1, y1. Then we substitute that into the gradient formula, and we end up having our final answer as negative 8. But remember, equation of a straight line is y equals to mx plus c. We already have the gradient, and we can use one of the coordinates or one of the points where the line passes, and then we can be able to use that point values x and y, the gradient that we have obtained as -8. Then now we work out the unknown value of c. Now substituting into that, we are going to have our c equivalent what? If you put that into your calculator and try to put the like terms together, you're going to realize that our c is equals to 20. Then now we can be able to write our equation in the form that was expected, so that we can be able to earn all the marks. If you're new to Proflan YouTube channel, take this chance to like this video and also subscribe, please, so that you can be able to grow this channel. In these videos of Proflan YouTube channel, in the Proflan Patreon page, where you can be able to join just for free, download the papers, so that whenever you are working out these questions, you are in a position of answering them as I'm doing the questions. You try to answer the questions first, and then maybe if there are some areas you find a challenge, you can be able to skip different questions, which are those ones that you are able to do, and then you focus on those that you are having a challenge. Moving to the next part, of this question in part D, whereby we are supposed to identify the inequalities which satisfy the region R. Remember, now we have the equations, and then now we can be able to see a line L, we know its equation. Yeah. So we can see some of the equation that we can identify first is that the shaded region is in front of y, so we can say y should be greater or equals to 0, and also the region R is above x axis, so meaning that we can say this is going to be also x is greater or equal to 0. The next part we're going to look at is the straight line. Yeah, the straight line here. Okay, first we look at the quadratic equation, and the region is above the quadratic equation, so we can say is y is greater than or equal to 2x squared minus 12x plus 14, and the last one is the region R under the equation of the straight line, so we're going to say y is less than or equal to, because it's just below the straight line, and that's going to be -8x plus 20. And then now I can be able to cut this section. I take it down there where it's supposed to, those inequalities are supposed to be. I can be able to paste them here, so that the examiner can be able to see the answers for that, and then we'll be able to earn all our marks. We move to question number 2. Question number 2 also is a question in inequalities, and we are told that figure 1 shows line L with equation x plus y equals to 6, and a curve C with equation y equals to 6x minus 2x squared plus 1. The line L intersects the curve C at the point P and Q. These two lines are going to intersect at those 2 points, P and Q, and we're supposed to find, using algebra, the coordinates of P. We're supposed to use algebra in order to find the coordinate of P. And now remember, from simultaneous equations, when you are having two curves, then if you want to find point of intersection, you're going to equate the curves, or you substitute one into the other. Then that is exactly what we are going to do. And we shall start by saying that in order to find P and Q, we are going to identify the first equation. And our first equation is actually x plus y equals to 6. We can say this is our equation 1. And then the other one, we can be able to identify it as equation 2. Now, we are going to approach this using substitution method. And then upon substituting, this is what we are going to have. put the like terms together, and of course we are going to have a quadratic equation. For us to solve this quadratic equation, we can be able to use a quadratic formula. Of course, there are other methods that you can be able to use in order to solve this quadratic equation, but for this particular video, I've given preference to the use of quadratic formula. And trying to solve this, we're going to get the value of x is 5/2, and the other value of x is equals to 1. Now we have the two values of x, and you see at any point you are solving a quadratic equation, you will have two solutions. In this particular question, we are finding coordinates of 2 points where they're intersecting. So one point will take the value of x 5/2, the other one will take the value of x to be 1. And the way to do that, for you to know what's the value of y, you are going to choose one of the equation. For instance, the first equation, we say a first equation was x plus y equals to 6. So we can be able to substitute to that equation x is equals to 5/2 and try to find the value of y. So we shall begin with substituting for p. We can now say p takes the value of x1, then substituting into one of the equation, we'll get the value of y for p is 5. And if we take q to have the value of x 5/2, then if you substitute 5/2 into one of the equation, you can be able to get the value of y. So we already have the point of intersection of the 2 points. Now let's see what is the next question that you are likely to be asked in this case. So I'm trying to shed some light that whenever you are going to do question with inequalities, they will be asking you to find point where curves are intersecting, and at the same time you may be required to find equation of straight lines. You may be expected to express questions to standard form completing square method. Also, you may be expected to come up with inequalities that define a region that is shaded. So you have to be quite open in the way you are going to approach different questions. So let us see the next question. You see now the next question is use inequalities to define the region R. We know the region R, right? We saw it. Here is the region R. You can see the region R is below the straight line, but it's outside or above the quadratic equation. Also, it's above the x-axis, right? So let us try to identify those inequalities. This is the region that we need to identify. So the first thing that we are going to say here, x plus y equals to 0, or x plus y equals to 6. That's equals to 6. So equals to 6. We can be able to rearrange that equation, and we can say now therefore that is y is less than 6 minus x. We can use that inequality. For the quadratic, we are going to say y is greater than, and also we can say x is greater than or equal to 0, y is greater than 0, because there is no region of R is below the x-axis or to the left side of the y-axis. So those are the inequalities that we are going to identify in that case. Can be able to put this inequality down here so that we can be able to proceed with the next question. In question number 3 is quite interesting. Yeah, I know this question. Some of us can forget and start multiplying x both sides. In fact, you cannot be able to approach this question that way, because we don't know if x is a positive number or a negative number. So in this case, we are going to multiply both sides by x squared. In fact, if you don't do that, you end up having one solution. So we're going to multiply both sides here, multiply both sides by x squared. And the reason as to why we are doing that is because we know very well that if you multiply a negative number in the inequality, what will happen is that it's going to change the sign of the inequality. So to ensure that we take care of this, if the number was a negative, still we take care of it, we are going to multiply both sides with x squared, which is a positive number. And that is going to translate what? We are going to have 3x is greater than 4x squared. Now we can be able to take 3x on the other side, and we end up having 4x squared minus 3x is less than 0. Now this is a quadratic inequality, and we're going to basically treat this inequality as an equal sign, so that we can be able to obtain critical points, and then so that we can be able to get the critical points of this quadratic. Thereafter we shall state the ranges of x and y. So we have changed the inequality to equal sign to enable us solve this quadratic. We get the critical points. Then once we get them, we can be able to state the range of values of x which can satisfy that. So we have the critical point x equals to 0 or x equals to 3 over 4. Then we can now be able to draw that representation of that curve. Remember, the quadratic was having a positive coefficient, so it will open upwards. And since we want values less than, we want below the x-axis, we want region below the x-axis. So we can be able to say this region, because the inequality was less than 0, so we take the region below the x-axis. So the values of x that defines that region are x is greater than 0, less than 3 over 4 as our final answer. That is for Roman 1. And then now we move to Roman 2. Roman 2, whereby we are told that the figure shows a sketch of the curve C and the straight line L. The infinite region R, shown shaded in figure 1, lies in quadrant 2 and quadrant 3, bounded by curve C and L only. Yes, we have this region at this given point. So we are supposed to use inequalities in order to define that particular. So we are told also there is a equation for C, and we are going to use that equation of C. Now, L has the gradient 3, C has the equation 2x squared minus 50. And so we have the gradient, but we don't know the y-intercept of line L. C has the equation y equals to 2x squared minus 50. C and L intersect on the negative x-axis. Use the inequality to define the region R. Now, in order to work out this, in order to know where these two curves are intersecting, the straight line and the curve C, we are going to solve that quadratic equation that we were given here. So we are going to say equals to 0, then we divide by 2 all true, and we end up having x squared minus 25 equals to 0. So this is a difference of two squares, and then it means we can be able to get the values of x to be positive 5 and negative 5. So you can see the curve C and the straight line are intersecting at negative 5. So meaning that coordinate is negative 5, 0. where the curve and the straight line are intersecting. So that means we already know where the straight line passes. We can be able to use the gradient 3 in order to get the equation of that straight line. I believe we are together that up to that point. So we have a equation where straight line is y equals to mx plus c. We have the gradient to be 3. Then now using the point that we have, we can be able to substitute into that equation in order to find the missing constant c. That becomes c becomes actually 15. C is equals to 15. And then we can be able to write the equation as shown here. Now, once we have the equation of a straight line, we can now go ahead and try to outline the inequalities. In that case, the first one that we can identify is the inequality that the inequality for this case. Let's see, y is less than or equal to 2x squared minus 50. The second one is for the straight line, because the region is above the line, so we shall say greater than or equal to 3x plus 15 as the required inequalities in this case. And we can see now also this region is basically below on the left side of the y-axis. So also we can add that inequality at that given region. Question number 4, the region R1 shown shaded in the figure 2 is defined by the inequalities that are given here, where k is a constant. The line x equals to a, we can see is vertically, and it also given that the area of R1 is 27 over 4 square units. That's quite important. That area is very vital in the process of working out this question. And we are supposed to find the value of k and also find the value of a in this question. The main objective of this question is to find the value of k and to find the value of a. Now, the first thing that we are going to do, we shall start by identifying what are the possible coordinates that we can know for this region R1. The first coordinate we can be able to identify is this, which is going to be what? A, because x-axis is x is a, so that is a2. That's the first coordinate. We have the second coordinate at this point, which is the origin 0 0. That's quite okay. Then we have also this one here. Okay, but we know y equals to 10 minus 2x. So at this point here, what is the value of x? We can be able to substitute y because we know at that point y is 2, so we can substitute 2 into the point where we have y and then try to find the value of x, so that it becomes x becomes actually 4 in that case. So we can say this coordinate is 4 2 because y is 2. Then we have another point that we can also try to look at is this point that we have down here. Still, we can use this equation that we have, and the way to do that, we know that on the x-axis y is equals to 0. Then we can go ahead and try to substitute 0 where we have y and then check what's the value of x in that point. So let me move this. Trying to substitute in, and we're going to get our value of x is 5. Then the y coordinate is actually the value of x is 5 and the value of y is equals to 0. Now, want you to pause there. Need to take some water. Now that we have the region R1 and we are told that the area of R1 is 27 over 4 square units, we have the coordinates for all the points of that figure. Now, the way we are going to do this, we are going to use the shoelace method, whereby we are going to apply the shoelace method, and the shoelace method is going to be a half, then magnitude. This is the symbol for magnitude or modular sign. The first coordinate we can start with is 0, 0. We write them vertically, and then we have the second one A2. The third one is 4, 2. We have 5, 0. Then we come again to the starting point, which is 0, 0. So the modulus means if you are going to work out the sum of the upper minus the sum of the lower, if you get a negative answer, you are going to take it positive. That's the reasons why we have the modulus. So we shall say that is equivalent to the area, which is 27 over 4. So in order to use the shoelace method, we are going to multiply. Yeah, we shall say now multiply 0 to a, like that, diagonal like that, but we have to start with a half, right? So that will be 0 times a will be 0, plus 2 times 4 will be 8, plus, right, 2 times 5 will be 10, plus 0 times 0 will be 0. We are done with that. Minus, of course, we are going to minus 0. 5 times 0 is 0. All right, so if we now try to work out this, we shall have 18 minus 2a is equals to 27 over 4. Then we can multiply by 2 both sides so that we can be able to make a the subject of the formula. Divide by 2 both sides. We are going to find our value of a is 2.25. 2.25. So that is exactly the value of a in that case. So this point is 2.25. Now, if you look at this equation that we were told, the equation of the straight line that is passing through the origin, it's passing through 0, 0, and also it's passing through the point 2.252. And you see the equation that was given is y equals to kx. K is the gradient of this line. So in order to find k, we are going to find the gradient of that straight line. And to do that, we are finding m, and that's going to reduce to what? That's going to reduce to 8 over 9 as our final answer in that case. Now that is the line y equals to 8 over 9x. So if we are stating the region of R2, R2 is going to be x is greater than or equal to 2.25, is going to be less than or equal to 8 over 9 x greater than or equal to the line the inequalities for the region R2 are going to be x is greater than or equal to 2.25. We shall also have it as y is greater than or equals to 8 over 9x. And lastly, we shall have y is less than or equal to 10 minus 2x. So we can move the inequalities and then put them down here so that we can be able to proceed to the next question. In question number 5, we are told the figure shows a sketch of curve C, whose equation is this. So the equation of curve C is y equals to a half x squared minus 10x plus 22. We are supposed to write the equation of C in the form a into x plus b squared plus c. We have already done this question, and then we use that form that we have expressed in order to state the minimum turning point of C. So we shall start by writing the equation and then factor a half out, and then we can now introduce the bracket. In this case, we shall have x minus a half of 20, then we shall square, then subtract a half, subtract the square of 10, then we multiply that by a half, which becomes 50, then plus 22. So meaning that our equation is going to translate to a half into x minus 10 x squared. Our equation becomes a half into x minus 10 squared minus 28. Now, in order to state the turning point, or the minimum point of this curve, we are going to take the opposite sign of this that we have here. So it will be positive 10, but 28, we take the negative sign the way it is. It's going to be 10 negative 28, right? So the gradient of the tangent is going to be equivalent to positive 8. So because m1 times m2 is equals to negative 1, that's where we got that from. Then we can be able to work out dy dx of the curve, dy dx of the curve, and the curve, remember, was this. So if we find dy dx, we are going to get x minus 10. But this dy dx equals to the 8 that we have here, then we can say now to x minus 10 equals to 8, then we get the value of x to be 18. So this is 18 into the curve so that we get to know what is the value of y when x is equals to 18. And if you work it out, you're going to get 4. So the coordinate becomes P8 at this given point. Now, in order to find the value of k, because this straight line passes through the point P, we can be able to substitute the x coordinate, which is 18, and the y coordinate, which is 4, into that equation, which will mean that that becomes 4 equals to k minus 1 over 8 into 18. If we try to simplify this equation, we can get the value of k to be 25 over 4 as the final answer that. Now let's look at how to identify the inequalities that define the region R. And already we did mention that this coordinate is 10, negative 28. So the minimum point there is, the minimum point there is 10, negative 28. And then this is, we can say 10, negative 28. So using this line here, we can say the inequality is going to be x is greater than 10. X is greater than 10. The second inequality is going to be y is greater than or equal to the quadratic equation a half into x minus 10 squared minus 28. Then we also have y is less than or equal to 25 over 4 minus 1 over 8x. In question number 7, we are given the inequality. Okay, so this is like a continuation of question number 6. And to solve the inequality, 4x squared minus 3x plus 7 greater than 4x plus 9, we are going to put the like terms together and ensure that we are forming a quadratic inequality. And thereafter, we are going to treat that as an equation, the inequality to be an equation, so that we can be able to find the critical points. So let us begin by rearranging the equation. This equation can be rearranged to 4x squared minus 7x minus 2. It can be rearranged to that, greater than or equals to 0. Then now we're going to treat that inequality as an equal sign so that we can be able to get the critical point. Solving the quadratic equation, we can get the value of x to be equals to 2 or x equals to negative 1 over 4. Now, once we have this, we are going to represent this on a diagram. We are going to represent that on a diagram. These are our critical points, and then we can draw a representation of that quadratic. So since it's having a positive coefficient, it's going to open upward, but the inequality was greater than 0. Greater than 0 means we want the region above the line. So greater than 0. So we want this region above the line. So the inequality, or the value of x that satisfies the line above the inequality above the line is going to be these values of x in this direction and the values of x in that direction only. So we shall say x is less than or equal to negative 1 over 4, or x is greater than or equal to 2. So those are the range of values of x which satisfies that inequality. Moving to question number 7, we are given the curve C that has equation y equals to 1 over x squared minus 9. And this equation, we are trying to learn how to do curve sketching when you have a graph like this one. So, but before I take you into this question, I need to shed some light that if you have the equation y equals to 1 over x squared, the graph of this is having a horizontal asymptote at y equals to 0, and also has a vertical asymptote at x equals to 0. So something that you need to remember is that asymptotes are lines where a curve approaches, but it never crosses or touches that asymptote. So if this graph is drawn, the sketch of this is going to behave that way, and also is going to behave that way. There's no way the value of y can be a negative because you see x is squared. Then that's the graph that we expect. We have the asymptote like that, and this is also another asymptote. Now we have this equation that we have down here is where now the asymptote has been moved 9 units down, right? The equation that we are given, y equals to 1 over x squared minus 9, is where the asymptote, actually that is the horizontal asymptote, has been moved downwards 9 steps. Now first we need to highlight the horizontal asymptote is going to be y equals to -9, and the vertical asymptote is going to be at x equals to 0. So we are going to have x and y axis. Our asymptote is going to be -9 down below here. Then next, for you to sketch effectively this, we need to know the x-intercept, because this line is not going to cut the y-axis anywhere. So we are going to have the x-intercepts, and at the x-intercept y is 0. So we can be able to substitute the values of x. The value of y is 0 there, and try to find the value of x. So if you divide by 9 on both sides and then find the square root, you are going to get x equals to plus or minus 1 over 3. And this will be -1 over 3, and this is positive 1 over 3. So the graph is going to go this way, and also it's going to pass that way, but the values where it cuts the x-axis are well shown here. To download this PDF, to download this marking scheme, you can be able to get that in Patreon page of Proflan. And also consider liking this video. Comment down below if there's a question that you really benefited from, so that I can also know that these videos are helping you out there. If you are new, consider subscribing, and please share this video to your friends also to benefit, in order to support the channel. The curve D has the equation y equals to kx squared, where k is a constant. This is a quadratic equation. Given that C meets D at 4 distinct points, D meets the curve C at 4 distinct points. Wow, those are many points. So how is this graph going to look like in order? Because this is a quadratic equation. D is a quadratic equation. So how is it going to be drawn so that it's cutting the curve that we have C in 4 points? It means it has to be facing down. That's my thinking here now. So I want to move this. I have part of this graph down here. Now let me just try to imagine for this quadratic to cut this graph that we have here 4 points. We have to have k less than 0, so that the graph is opening downward, so it turns like that. Yeah, that's the only way you can be able to cut this graph into 4 points. It will be able to cut it at this point, can cut it at this point, and also so we have 4 points. Also, we are told distinct points, meaning the discriminant in that case must be greater than 0. So we are going to equate the two curves together. Then once we have equated, we are going to have a quadratic equation, and then try to use that quadratic equation in order to come up with the discriminant. And the discriminant now we shall say is greater than 0 in that case. So equating the curve kx squared to 1 over x squared minus 9, we can multiply by x squared all true, then we shall have k raised to power 4 equals to 1 minus 9x squared. So in fact, this is a quadratic equation, because if you can let m be equal to x squared, you can be able to write this equation as km squared plus 9m minus 1 is equals to 0. Even though this quadratic is actually written x raised to power 4, it's a quadratic in quadratic form. It's only that x is squared. Now we can just treat it now as a quadratic equation, and we can be able to find the discriminant in that case. And let's see. Discriminant, how is the discriminant obtained? Discriminant is b squared minus 4ac, which is greater than 0. Greater than 0. So putting the like terms together and taking 81 on the other side divided by 4 both sides, we're going to get k is greater than negative 81 over 4 in that way. So the range of values for x, rather k should be greater than negative 81 over 4 or less than 0. K should be greater than negative 81 over 4 but less than 0. We have question number 8, and I want you to follow through keenly in this question. This also is the testing the concept of discriminant, and something I would like you to realize at this point is that we are going to multiply both sides by x plus p in this given equation. Then once we form an equation or a quadratic equation, we shall use that quadratic equation that we are going to get and find the discriminant. The discriminant is going to be greater than 0 because we are told two distinct points. So right now I'm just putting the like terms together so that we can be able to form a quadratic equation in terms of p. Taking this or dividing all through by negative 1 so that we have positive coefficient in x squared, we shall now have 8x squared plus 4px minus 4p squared. Then on the other side we have this, which means we are going to take it on the other side of the equal sign, equals to 0. Now this is a constant because 12 is a constant, p is also a constant, so all of these three terms here that I've put in brackets, they are constants. They are going to represent c in the quadratic that we have here. Our quadratic is 8x squared plus 4p. 4p is the value of b in this quadratic equation, and 12 plus 15p minus 4p squared is the value of c. So we can be able to find the discriminant. Discriminant, remember, is b squared minus 4ac. But since we are told two distinct roots, real roots, we shall say discriminant is greater than 0. So trying to identify, our a is 8, our b is 4p, and our c is 12 plus 15p minus 4p squared as one term. So substituting into that formula of discriminant and putting the like terms together, we are going to land and have our equation resulting to 144, because if we open the bracket with that 2, yeah, so this is going to translate to 144 p squared minus 480p minus 384 is greater than 0. So remember, we want to arrive at 3p squared minus 10p minus 8 is greater than 0. We can divide all through by 48, which is going to reduce to the expression that was required in this particular question. Hence, we are supposed to use algebra to find the range of possible values of p. So we are supposed to solve the quadratic equation 3p squared minus 10p minus 8 is greater than 0. We are going to treat the inequality as an equal sign so that we can use a quadratic formula in order to solve for p, and p is 4 or p is negative 2 over 3. So since we need the region above the line, so we shall say p is greater than negative 2 over 3, or rather p is greater than 4, or p is less than negative 2 over 3, like that. The last question for this video, we are going to look at this figure whereby we are told that the figure shows the curve with equation y equals to fx, and we are given the points p is negative 4, 6. P is negative 4, 6. We have another point, p is negative 4, 6. We have another point there, negative 1, 6. We have 2, 6. We have 3, 6. And I can draw a straight line across that passes through the y-axis at 6. Now, we are supposed to find the range of values for x for which f of x is less than 6. F of x is less than 6. Less than 6 means we want the values of x which can give the graph below the line that I've drawn, the yellow line. So in that case, we need values that satisfy this curve down here. We need values of x satisfy this curve here, and we know the values that satisfy this curve here. And the first one here is x is less than negative 4. Strictly less than negative 4. If you put less than or equal to, you get it wrong. It's strictly less than negative 4. This other part here, this region here, is defined by the values x is greater than negative 1 but less than 2, like that. And this other region is having values that can satisfy that is x is greater than 3. Those are the only values which satisfy that. Take the largest solution. Of the equation f2x equals to 6. f2x equals to 6. Now, something that you need to remember is that whenever a transformation is taking place inside the bracket, it means only the x coordinates are going to be affected. And in this case, the x coordinates are going to be affected in the sense that you are going to divide all those coordinates of x by 2. You do the opposite of what you are told when the change is the transformation function is in the x, or rather is inside the bracket, right? So we are going to check all the values of x and then divide all through by 2, and then we're going to get our x being equal to 1.5. X is equals to 1.5 as the solution for that. In part C, we are told to sketch the curve with y equals to negative x. On your sketch, state the coordinates of the points P, Q, R, and S are transformed. Hence, find the set of value for x which f of negative x is greater than 6, and where x is less than 0. And also this is a transformation whereby it's in a bracket multiplied by negative x, which means this is a reflection on the y-axis. This is a reflection on the y-axis, which implies that all the coordinates of x are going to have the opposite sign. So like for instance, if we were having negative 3, now negative 3, 6, it will become positive 3, 6. If we were having negative 2, 6, that coordinate will become positive 2, 6. If we were having negative 1, 6, that coordinate will be transformed and become negative 1, 6. If we were having 4, positive 4, 6, that coordinate will become negative 4, 6. And upon drawing that graph, that graph will behave like this. It will be a reflection on the x-axis. So the coordinates will be appearing like that. And then now the last section, because we are interested with where x is below x is less than 0, so it will be on the left side of the y-axis. So it will be this section over. It will be x is less than 0. That's why I'm using this region here.